Charlotte. It's great to have you on the show. Thanks for coming on the Mr. Beacon podcast.
Well, it's great to be here, Steve. I've been a big fan of Mr. Beacon for a few years now, so it's such an honor to be here.
Well, we met, I think it was at CES, wasn't it, in Las Vegas, and I got to see your technology, and months have gone by, and we've been meaning to record this conversation. So tell us a bit about the company that you founded.
Yeah, definitely. So HaiLa Technologies, we founded August 2017. We are an ultra-low power communication platform, and our goal is to enable battery-free sensing for IoT sensors. And essentially what we do is that we use existing infrastructure in our environment and piggyback off that to eliminate the power consumed at the radio down to next to nothing. So you can imagine a standard radio protocol creates a signal at the wireless device and sends out that information. What we do is that we actually jump on top of existing signals in your environment. So you can imagine at 802.11 standard Wi-Fi signals going back, in your apartment, for example, right now. And instead of, adding to that traffic and having, your temperature humidity sensor that connects to your smart thermostat, instead of creating signals, what we do is we just piggyback on top of existing signals. The original term actually coined was called hitchhiking. So that's essentially what we're doing right now.
I can't believe it, because, 6 years is a long time. Wiliot, the company I work for, we're both in the same kind of space. And I've never used the hitchhiking metaphor. I can't believe it. I can't believe that it's been this long. I love it. So you're focused, or at least initially, on Wi-Fi, so that's interesting. Our Wiliot's been focused on the Bluetooth area. How do you do what you do? So I think it totally makes sense to tap into all of the radio waves that are surrounding us. It's more sustainable, less need for batteries, lower power consumption. But it sounds tricky. Give us a sense of what you do, because you're using something called Backscatter, which I actually don't think we've really explained, certainly not recently on this podcast. So it'd be great if you could.
Yeah, definitely. So Backscatter is the foundational technology for RFID, which everyone knows that works all around the world, in basically shipped in the billions. So it's basically been tried and proven in that space. What we're doing is that we're adapting it to Wi-Fi first. So instead of having extremely expensive RFID readers, we are actually leveraging your existing Wi-Fi infrastructure to read our hopefully battery-free sensors in the future. So our technology relies on existing infrastructure, and that's where passive backscatter really, comes into play. So what we do essentially, maybe I can take you through our products. We are a semiconductor company, both on the software side and the hardware side. So our first ever chip that we taped out was put into this little demo kit over here. So you can see that it's, quite bulky, about the size of a credit card, a couple inches thick. And here we have our first ever ASIC, so application-specific integrated circuit chip right over here, that black little square, and everything else is run on FPGA, field programmable gate array. This is essentially to prove our concept and to prove that we can actually suspend disbelief and that this works over Wi-Fi.
So you talked about taping out. Did my job for me explaining the other acronyms, but what does tape out mean?
So taping out means actually producing silicon. So that's having a chip, which is a more likelihood form factor for commercialization, where customers can integrate that into their existing sensors, for example. So taping out is a well-known nomenclature in the semiconductor space for actually having your silicon.
Wonderful. Thank you. I didn't mean to interrupt your flow. So you showed us version 1, which is smaller than the average Wi-Fi device, but I suspect you're going to show us something even smaller.
Well, Our goal, like we talked about, I think Wiliot has the same vision, is to eliminate batteries from these type of sensors. We can talk about the whole landfill problem in the future and why, this power consumption bottleneck is really affecting both IoT growth. It's both affecting the sustainability factor of IoT and much more. So our second product that we have over here, we have our second chip there. So you can see, once again, 180 nanometer silicon. And this is really exciting. So we had our second chip taped out, fresh out of the labs actually last week. We brought it to Sensors Converge in California to showcase it for the first time. And the goal is to, one, decrease the form factor, and two, prove out this technology again. So we've done that. We have both our digital and RF front end on our chip, which means we got to eliminate the big clunky FPGA that I mentioned prior and the big battery on the back. This will run off a coin cell, CR2032, for about 2 years. And this is still a prototype version that we have since it's our first, digital and analog chip that we have. So the golden standard for Wi-Fi communication in the space right now is 263 days running off a coin cell CR2032. And already with our prototype, we have that beat in terms of power consumption. Like I mentioned, 2 years. The next version of our chip that will be coming out in about 18 months, we're looking at 20 to 40 years of battery life on a coin cell CR2032. I'm cognizant that these type of batteries degrade over time and don't even last 20 to 40 years. But the point is to prove that we can really drive the power consumption floor for communication down so low that, these sensors can be embedded within walls, embedded within flooring materials, embedded, within bodies as well, to be able to last that certain amount of time. And the goal after that actually is to have a completely battery-free solution harvesting off of RF energy, which means you can imagine in a world that you have Wi-Fi infrastructure already, we're piggybacking on top of it, and at the same time, we're also harvesting. There's a lot of solutions out there right now that require gateways, right? That require gateways to flood the area with energy, just like RFID is using. And there's also a lot of technologies out there that have ultra low power communication platforms, but they as well are proprietary and take gateways. Our goal is to use the existing infrastructure because I believe that's the way that we're really going to scale this type of technology, is by partnering with the Wi-Fi equipment makers and using what is already there to our advantage. And, Wi-Fi is very ubiquitous. I believe that Wi-Fi's trend will continue going in the right direction, and it should be the golden standard for indoor communication. So that's a little bit about, our products and why we chose Wi-Fi.
What kind of range are you getting with this Gen 2 product?
So that's a great question. So with our Gen 2 product, we haven't completely characterized the range, but we're looking at, room coverage. So around, 500 square feet. Our goal with the next one is to get full floor coverage. And we actually have a path to have 3,000 square feet coverage in a standard, American, Canadian home with 3 floors. But that's leveraging the existing Wi-Fi access points and potentially other powered Wi-Fi devices.
Very good.
It can make sense to talk about 802.11 AMP study group that's happening right now with IEEE, because that has a big factor in getting this full coverage. So this new study group has been going on for the past year. I'm really grateful because our chief scientist, Vitas Kezis, who participated in BlackBerry's first ever Wi-Fi smartphone, he is representing HaiLa at the 802.11 AMP study group. And it's been such an amazing process to see this entire organization focusing on the importance of ambient powered IoT. So that's been really incredible to watch that progress. And I know that Wiliot and HaiLa both have, showcased our demos there, suspending disbelief and really trying to push this within the standards to be able to put a few things in the protocol, put a few things in 802.11 AMP to help increase coverage, for example, for backscatter, such as joint transmission, beamforming, etc.
Yeah, I'm glad that you brought up that new Wi-Fi 802.11 AMP or ambient power activity that's going on. And as you said, we're both active in that. And I think it's kind of there's a parallel activity going on in 3GPP, the third generation partnership, which is the organization that is driving the 5G advanced and 6G standards. And we're actually hearing rumbles for other secondary wireless protocols that they're starting to work on ambient standards as well. So it's very exciting. And I think, we're dancing with giants here. The work that Wiliot's doing over in parallel in the 3GPP group, the folks contributing to those standards are companies like Apple and Qualcomm and Huawei, and Wiliot's very active. And I think both your company and ours get an outsized influence relative to the number of people we have in our company, because we have working solutions. And so we're able to prove that these concepts can actually be achieved. And that's just so helpful. When in standards, when we first heard that it was realistic that there would be open standards for ambient power, I'm like, oh, we're just going to get steamrolled. But I think, worse, it just will end up with something that doesn't work because, everyone's got an opinion on the right thing to do. But fortunately, there are companies that, like yours and like ours, that have got working products and customers and that sort of thing. So that really helps to focus the debate in more constructive ways. And I think the opportunity for addressing some of the world's biggest problems, I'm not saying this is a panacea, but certainly there's a lot of amazing applications for this technology. So maybe we should, unless there's anything more that you want to say on the standards activity, we can start to talk about the applications.
Yeah, definitely. Maybe a little note. I think that it's so amazing, that Wiliot and both HaiLa are working on this. And I think that, Bluetooth has such a space in the personal area network. And I don't think that that's going anywhere. I remember the day that the press release came out that Wiliot raised $200 million from Amazon, SoftBank, Avery Dennison. That was such a big moment for me. A lot of people were like, aren't you afraid? I'm like, no, this is amazing. I believe that we have to be collaborators and enablers to get this technology out there, because the golden standard is not good enough right now. And I think that it's so important to have, the startups that are focusing on the innovative technology for, ultra low power communication. So I'm just glad to be here and talking about these really important subjects.
Yeah, I mean, you guys have been going for a long time. In startup years, you've been going a long time. So you're obviously doing some things right. What's the sweet spot for applying this technology that you're working on?
I think that's kind of a two-tiered answer. The first sweet spot I feel like is, really replacing the existing standard for ultra-low power communication and being able to eliminate batteries and existing sensors that are already out there. I think that we know that, all of these different types of statistics that have been out there about 100 million batteries will have to be replaced every single day in, 10 to 15 years from now. And I know there's a lot of statistics that are way worse than that, but I chose a conservative one because I'm Canadian and that's how we do. But I think that's terrifying. And I think that it's so important to have sensors, especially with current events that are happening around the world. For example, the wildfires in Quebec, and being able to have air quality sensors that show us, okay, now you have to close the doors. We don't want these, particulate matters that are stuck in our lungs and our airways. That's just one really great example. So eliminating batteries from sensors that exist already. Oh, great. Number two is enabling all these new types of applications with battery-free sensors, like embedding them within walls. I think I mentioned before, embedding them in rooftops to detect smoldering fires, the potential for smoldering fires, to detect mold, to detect humidity, even to have sensors on your personal area network that are monitoring your health. So that you don't have to have, right now there's a lot of duty cycling, so you're missing a lot of really valuable data. So continuous monitoring without needing batteries, this is really important. And I feel like, even for HVAC systems, building automation is a really huge sweet spot for HaiLa. We realized, I started off in the med tech space. I love this technology for, medical implantables, for medical wearables. That was a long path to market. I started realizing that building automation, they were hungry for this type of technology. They started buying prototypes from us. We started engaging with them very early on and being able to really optimize energy spent in a smart building, or even, retrofitting older buildings. There's way more potential there in eliminating wasted energy. And I think that's a really important place for, battery-free sensors to live, to really automate, how much are we creating in pollution? And then there's the whole other world. So that's the sweet spot for HaiLa, but I know the sweet spot for Wiliot, and also, potentially a future sweet spot for HaiLa, is really making sure to create accountability in corporations and consumables, making sure that you're tracking everything that a corporation is creating as a product, having these sensors in it, just like Wiliot is doing, making sure that we know that the entire accountability chain is known, right? How are these landfills getting filled up? How are they almost at capacity in North America, in Canada? I was doing some research this morning, and for US landfills, 7 states are running out of landfill space in 5 years, 1 state in 10 years, 3 states in 20 years. So, in 22 states, they have a few decades left. So, 9 out of 38 sites are full by 2030. 13 others full by 2041. This is insane. And even in my hometown of Montreal, we're looking at, really awful landfill problems to reach capacity as well. And I don't understand how we're creating this problem for future generations, and so I see that this technology really can live well within our society to help improve us and not be this generation of pollution that I think that we will be known to be for, centuries to come.
Yeah, I hear. I agree with the sentiments and what you've said there. I'm actually hoping to get another guest on this show fairly soon, who's written some incredible books on the subject of climate and carbon, and it's been very interesting. We've had the privilege to have just a preliminary conversation with him. It's pretty amazing that you get to read a book, you love it, and then you get to have a conversation with the author. So I'm hoping that we can persuade him to talk in this show. But his name's Mike Berners-Lee, Professor Mike Berners-Lee. And if anyone kind of wants some help in getting through the FUD and reading some incredibly intelligent, scientific, but also human, funny perspectives on climate, then I recommend his books. And there's 2. There's one that's called How Bad's a Banana, which that was the title for the British market. In the Americas market, it's the carbon footprint of everything. And the premise is that we're kind of generally fairly illiterate in terms of what the carbon footprint of things is, and turns out bananas are actually good, but there are other things that you wouldn't know it are bad, and that's why it's worth reading the book. But there's another one that I just finished. I finished it in 3 days, which is called There Is No Planet B, as in there's no plan B, there is no planet B. And it's basically, he exercises some opinions, some recommendations on what we can do. And basically, I ended up cycling to work, not every day, because it's not practical for me to do it every day. But I bought an electric bike, and I'm now doing that because that was one of his recommendations, changing my diet, all sorts of things. So anyway, I'm sorry to drift away from what we were talking about, but clearly, I think one of the golden applications for Ambient IoT is empowering consumers to know where their food comes from. It's one of the biggest things we can do to make a difference. We recently hired our VP of Climate, Anthony Yusefian. He likes to say we can eat our way out of climate change. It's probably not just eating the right things, but if we can eat food that has been grown in farms that are actually capturing carbon rather than throwing it into the atmosphere, it can make a huge difference. And it turns out when you do that, you end up eating food that's really good for you and tastes better. So, but how do you know where it's come from? And I think Ambient IoT can give people, the full story of where their foods come from, how it's been treated, what the carbon footprint is, how the land and animals were treated, and all that sort of thing. So back to you.
I totally agree, Steve. Yeah, no, I totally agree, and I really love this topic because I think regenerative farming is really important, and also indoor farming at warehouses and city centers. We've spoken a lot to indoor farming folks and the importance of having sensors. A lot of them right now, they still wire up all of their sensors because they don't really have any ultra low power wireless solutions. And a lot of the prospective clients and partners that we have right now, B is the bad word. We don't talk about batteries, because no one wants to deal with, you have a sustainable company, you have a company that you care about the environment, you're trying to capture carbon, and then you have to have batteries and sensors to create a better yield, to monitor the products that you're making. And it really is counterintuitive to what we're all trying to do. So I think that that's really amazing, both on, the accountability chain that we mentioned about where your food's coming from, what the temperature is, how is it cared for along the entire process, who's involved in that, are people being paid appropriately along that line too? And also just, transportation is one of the biggest pollution aspects too, and keeping it close, right? Keeping it local. And I think that that's really important. And, some of the smart farming applications that we looked at, there's Wi-Fi that exists already. You can imagine they want sensors below the leaf, on top of the leaf, measuring, circulation, measuring humidity, measuring temperature. So all these things are really important to have an optimal yield at the same time. So they're not creating waste too, having pests come in and you don't catch them fast enough. So they've basically, proliferated to the entire floor of tomatoes that you're growing, for example. So I think that there's so many applications that we could spend days talking about the importance of battery-free sensing and what that enables for the consumer, for the corporation, and for the planet as a whole, and the benefits that it could bring to us.
Amazing. So, Charlotte, how did you end up starting your company? Tell us the founding story.
Yeah, definitely. So I studied engineering here in Montreal, Concordia University. I fell in love with biomedical applications, and I got a job at McGill University, actually, working for Dr. Ed Harvey, Chief Orthopedic Surgeon at McGill University, on the orthopedic side. And he was developing a product, so a sensor that goes in the body, reads the pressure wirelessly, so surgeons know when to intervene. And I was one of the first, engineers on the team, working on the prototype. So we had to go find, a sensor on the market, find a radio on the market, do all our calculations to see what type of power management we're going to need, what type of power source. And I was very naive at that time. I had just started engineering. I was like, we can use energy harvesting. Like, why are we using batteries? This is insanity. And then I do all the calculations with the golden standard for ultra low power communication. And we needed a battery pack that was about this big. So like the same size as this demo, essentially. And there is a little sensor that would be inserted in your body. And on the outside of your body, this big battery pack would be stuck for 48 hours. So, from 48 hours to 7 days, you have this stuck onto you. And then once you're finished at the hospital, the entire device, including the battery, goes into hazardous waste. And that made me feel very sick to my stomach. And I started looking up, the power consumption bottleneck in all IoT devices and the amount of batteries on all these wireless sensors and how they're completely discarded into waste after they're used. And I was like, this doesn't make sense. I understand the fundamentals of energy harvesting. I understand communication. But I was kind of halted at the power range of, throughput triangle that we're taught in engineering. But I knew that there had to be a better way. I knew that there was room for innovation, room for improvement. So I started looking at all different types of, establishments, academic literature, industrial literature, see what was out there, see how we can do better. And I actually met this German investor called Helge Sietzen at the McGill X1 Accelerator. So I was lucky. I was in this summer boot camp, which is amazing. They brought over 100 entrepreneurs from all around the world to educate me about obviously being comfortable with failure, because that's the ongoing theme in entrepreneurship. And Helge was one of these investors that came. And I pitched to him this power consumption bottleneck in, medical implantables. And he was like, Charlotte, this is a problem across the spectrum. This is a solution that, this is a problem that we can really find a good solution for. And he introduced me to, so if you don't know, TenumLaunch is known for their ability to license technologies from prolific universities around the world. They have an entire staff dedicated to this. So I was really lucky to enter this organization and really, look at all the different types of technology that we're working on this. And so there was some technology that came out of Stanford University. Instead of creating the signal at the wireless device, like Bluetooth did for my pressure sensor at the time, this technology actually leverages the existing infrastructure and piggybacks on top of it, which is passive backscatter. So that kind of defeated the laws of physics that were in my head about power, range, and throughput. I'm like, this is incredible. So not only are we piggybacking off infrastructure that is powered, so you essentially, you're beaming power towards these sensors so they don't need batteries. Well, in this technology, you're using existing infrastructure like Wi-Fi. And I was like, wow, because gateways are definitely a massive bottleneck for IoT to proliferate to the numbers that it's been saying in market research for decades now. So when I saw this technology from Stanford, I'm like, that's the solution. That's what's going to fix this. And, obviously there's a lot of other companies that were working on Backscatter, but I really loved this type of technology from Stanford that utilized the existing infrastructure that didn't require gateways. And so essentially, that's when HaiLa was born. So we ended up getting 3 exclusive patents, licenses for patents from Stanford University. HaiLa put in $400,000 in convertible note at TenumLaunch, and we ended up growing the team, growing out the different products. We actually raised 3.7 million USD 10 days before the pandemic was declared. So that was a journey in itself. Before that, we ended up doing a lot of different type of competitions, a lot of applications to non-dilutive funding to get some cash in the bank. We ended up winning the Open Innovation Award at Bell Labs, Nokia Bell Labs, which was huge. We actually were able to convince our first board member to come on as an advisor, Sam Haidari. So Sam sold Quantenna to onsemi a few years back. He's a leader in the Wi-Fi space. So having him come on board to be our first technical advisor was massive. So after that, we closed our round of 3.7 million USD. The COVID project was what you see over here. So we were able to do that, ship it off to our partners right before Christmas last year. And then we also did a deep application and diligence with Sustainable Development Technology of Canada. We were granted $3 million of non-dilutive funding to focus on these type of projects. So that was really wonderful. And since then, we've also raised another round, about $5 million as another seed extension round. And we've been going forward, just trying to miniaturize our product, get the lifetime that we need, work on requirements with our customers. And I think the biggest end goal is to get this out there, right? And have this working in a real life environment.
And what can you say about the partners, customers that you're working with?
So I can say that they're mostly in the building automation space. They're in the Wi-Fi equipment makers, they're in the chipset makers, and the sensor end users. So what's really beautiful and challenging about this technology is that it's an ecosystem play. We're helping all members of the ecosystem enable this type of battery-free operation. That also comes with a challenge because it means that you have to be handshaking nicely with everyone, which I think our team is really capable of doing. And I think the proof is in the pudding, and I think we're on our way there, which is really, really exciting.
Yeah, I love this conversation. I'm thinking we've covered a lot. Is there anything else that you want to say before we wrap it?
I think that we definitely covered, the majority of it. And I think I just want to reiterate, how wonderful it is to meet with you, Steve, and to continue working. And I know that in the 802.11 AMP, we have Amakai and Vetus working, side by side to get this technology out there. And I think that, we mentioned a little bit about active transmit prior in our prep. And that's something that's really interesting also. So active transmit is, a different version of backscatter where you don't necessarily need, the full features to help get that ultra long coverage that we were discussing, 802.11 AMP. Active transmit is potential to get a stepping stone to get to backscatter. So backscatter really works well in high density environments, high density sensor, high density access point environments, But on a stepping stone to getting there, active transmit may be a really great solution to showcase the importance of having these sensors out there, ultra low power communication for active transmit. And I think that's really interesting topic that I think is going to be flourishing over the next years alongside Backscatter.
Yeah, and in case people are wondering, I was wondering whether to mention this, but the Wiliot's approach is active. Actually, I remember when I joined the company, I joined in with the expectation that we were going to be using Backscatter, and then we basically did a little technical pivot, and so all of our chips have been active, which basically means you can potentially take a weaker signal in, accumulate it over time, and then send a stronger signal out. I think you've got a great video on your website that illustrates Backscatter with the concept of signaling with a mirror, where you take like a very bright signal like the sun and you reflect it back, and the signal's weaker, but you've remodulated it to go in the right direction. Probably haven't done your video justice, but I recommend that people go to your website, which is HaiLa.io, just in case people are wondering. So, Charlotte, we've got to the part of the show where you share 3 songs that have meaning to you. What was your choice?
It was a really hard question, Steve. I think it was the hardest prep that I had for this podcast because, narrowing it down to 3 songs, that's hard. So I think that you wanted me to relate them to times in my life. So I guess my first favorite song was A Dream On by Aerosmith. And I used to listen to that song every single day coming home from school, just thinking of what life is going to be like when I wasn't trapped in the 9-to-5 school system.
Just before the second one, but so where did you go to school?
I went to school in Villa Maria in Montreal downtown, so not far actually from our office right now.
Oh, okay. Well, that sounds really nice.
Yeah, it was really nice. It was actually an all-girls Catholic school, and being raised as an atheist, it was definitely an interesting experience. But an amazing school with amazing physics programs and science programs. I was really lucky to have that type of exposure early on.
Oh, right. Very good. Okay, so that's song 1.
And so song 2 is Freebird by Leonard Skinner. So that was definitely a favorite for me, maybe a little bit growing up past high school, understanding what the world was about and really being able to connect with my passions and, being able to really focus on what I love to do. And, I guess that was definitely physics and science for me.
All right. That was definitely something that was played a lot when I was in college. So it's interesting that some good songs persist, because I'm thinking that when you went to college and when I went to college, it's slightly different eras. But it's a great song.
Definitely, but you got great music. I mean, we have good music too, but I definitely like classic rock.
Yeah, indeed. Very good. And so what's number 3?
Number 3 is Here Comes the Sun by the Beatles. And I think that really relates to my entrepreneurial journey because, as I'm sure you know, Steve, things can get dark and cloudy sometimes. So always knowing that, the sun rises the next day and always knowing that you can start fresh and new has been a really good perspective for me.
Well, Charlotte, it's been a real pleasure. I know that we're going to stay in touch, and it's great to hear that our members of our team are working well together in the Ambient IoT standards area. I really admire what you've done and congratulate you. And I look forward to seeing you in person the next time our paths cross.
Thank you so much, Steve. It's been a pleasure.
Thanks for watching this episode of the Mr. Beacon Ambient IoT podcast here on YouTube. You can listen to this episode on iTunes, Spotify, or wherever you get your podcasts. If you enjoyed it, please like and share this video. And be sure to subscribe for more videos. For more information about Wiliot, Ambient IoT, and IoT Pixels, head over to wiliot.com.